Okay, in this video, we are going to talk about finding z-scores given an area under the curve. Okay, so this problem is essentially the reverse of what we have been doing previously in section 6.2. Okay, so before, what we were doing is we were given a z-score or a couple of z-scores and asked to find an area under the curve, um, between or to the left of or to the right of that those z-scores. Okay, so this time we're given the area and we want to find the z-score. So here you can see the problem here, right? We're given, hey, this region has an area underneath the standard normal curve, has an area of 0.54. So what would this z-score be? Okay, so again, that's backwards of what we've been doing. All right, so what we would have to do is basically go look through the body of the table this time. Okay, and we're going to look for a number that's as close as we can possibly get to 0.54. All right, and so let's go do that. All right, so we're looking at these numbers this time, right? 0.0 or 0.54, right, was the number. So here they're getting a little closer. 0.5 is right there, right? And we keep going. We got 0.539, 5359 rather, right? That's pretty close to 0.54. And then here we have 0.398. That's very, very close, right? And between these two, right, this one is actually a little bit closer, right? Because if you did the subtraction with 0.54, let's just do that, right? 0.54 minus 0.5398, right? That's this number here, and then the other number 0. We were looking right in here, 0.5438. And we're not worried about the sign, just which one of these two numbers is smaller, right, in absolute value. So you can see, so really we just want the absolute value, and we're looking for which one of these is smaller, right? And so it would definitely be this one, because that's a smaller number than this, right? So that means that between these two, right, 0.5398 is the closest number in the table to 0.54, right? So we found this number in the table, and now what we need is the z-score that corresponds to it. So the first digits are going to be 0.1, right? And then this one is going to be 0 right here, okay? So look out here to get the first two digits and look up here to get the third digit. All right, and so that's that z-score there. So now we know, hey, the number that the z-score that has an area of 0.54 to the left, right, would be 0.100. Okay. Okay. There is a notation that's used called the z alpha notation, and that is used to denote the z-score that has an area of alpha to its right under the standard normal curve. Okay, so that would be over here to the right. So z alpha would be the z-score that has an area of alpha, right, to its right over here. Okay. All right, so let's take a look at an example of that. All right, so z of 0.03, okay? That's what we want to find. So what would that be? That would be the z-score that has an area of 0.03 to its right, okay? So how would you calculate that out? Well, obviously we would be using table 2, right? But the thing is, table 2 gives the area that's over here to the left, and this is Z alpha notation is the area to the right. So how would we do that? Well, all we would have to do, right, the area to the right is 0.03. That would mean that this area over here to the left would be the total area, which is 1, right, for these density curves, any density curve, in particular the ones that we're looking at, right? So all we would have to do is subtract, right, 1 minus 0.03, and that gives us 0.97. And so what we would do is go look up 0.97 in the body of the table. So let's go do that now. All right, so 0.97 is what we're looking for. 0.97. So here we have 0.9699 and 0.9706, right? And the one that's closest to 0.97 would be this one right here, okay? 0.9699. So we would go look, right? The first two digits would be 1.8. And then that last digit will be an 8. So it would be 1.88 on that one. Okay. All right, so that Z-score is 1.88. So Z of 0.03 is 1.88. It has an area of 0.03 to its right. All right, next up what we want to do is to find two Z-scores that divide the area under the standard normal curve into a middle 0.86 area and two outside areas, 0.07 areas, as shown in the figure right here. Okay. All right, so the first thing we're going to do is just kind of proceed like we did before in this example. We're going to subtract 0.07 from 1, and that's going to give us 0.93. All right, and so we would go look up 0.93 in the body of the table. So 0.93 would be the area below that upper number there. So 0.93. Okay. So this one, it's between this one and this one, right? And this one, right, is the one that's closer to 0.93, right? It's 0.0006 when you subtract it or look at the difference, the absolute value of the difference, whereas this one would be 0.000 or 8 there. Okay. So it's 1.48. Okay, so that's 1.48 right here. And then because the normal curve is symmetric, we don't even really need to look this one up. We know if this area and this area are going to be the same, it's got to be the opposite of this one, right? And again, that's exploiting the symmetry, right, of the normal curve in this case. Okay. All right. And so that's it for this one, and we will work through some more examples.